Perfect. All right, so for DNA mutations, the first one is called substitution. And if we're going to show a substitution mutation, I'm going to start with some basic code. So I'm going to start with CCA TGT. Now, how do I know that's DNA code? There's no U's, but there are what? T's, okay? Now, on the test, you should do this. Anytime I give you code, you should break it into the three-letter reading frame. So, okay, we'll say the first three letters were CCA, the second three letters are TGT. Now I'm going to mutate this code via substitution to this. Now, if this is my mutated code, I'm going to still break it into the reading frame. And now by looking at this code, can someone tell me which letter or base actually mutated? The A became a, so I want you to circle it. This became this. That's a substitution. Now we're going to do this on just this one, okay? But if this is the original code in DNA, what RNA would this have originally coded for? In RNA, C would bind to C, A, U. Now over here, this is what it mutated to, right? But the C would still code for G in RNA, G and C. So the letter of DNA has switch, which would technically make the RNA letter also what? Switch. So now if we look up here, GGU codes for glycine, and it mutated to GGC, which codes for glycine. So the DNA has mutated, but has the amino acid changed? Which means has the protein changed? Okay? So that's why I could be genetically different from Noah, yet we could both be building insulin protein perfectly. Does that make sense? Because my code may be different, but I might still be putting in the same what? Amino acid. Now I want you to look at this. Let's imagine the letter that mutated wasn't the last letter. Let's say it was the second letter. Let's say I had mutated it so it was actually GCC, right? Or sorry, it was normally GGU. I'm going to go back here and show you. It was normally GGU, and let's just say the second letter was the one that mutated, and it became GCU. Make sense? So if it had become GCU, would the amino acid have changed?
Yes.
If it had become GAU, would it have changed? If it became GUU, would it have changed? Yes. So even if I jump to a first letter change, would it most likely change? Yes. So what does that reveal about the codon chart? Where are the mutations less damaging? On the last letter. Does that make sense? If you change the first or second letter, you can pretty much guarantee your amino acid is going to change. If it's the last letter, it might or might not. Okay? All right, so let's go to another one. Let's do insertion. Okay, for insertion, we're going to start with the same code, CCA TGT, bracket, bracket. Then I'm going to mutate it to this. Now, if that's how it mutated, I write my reading frame, I bracket. And if I had to look at the code, where did the insertion mutation occur? The T. So I'm going to circle my T, and I'm going to put an arrow in, because that's what insertion does. It puts a whole new letter in the original sequence. Now, I want you to estimate. We don't even have to look at the chart, but would you say this first mutation, would it change the amino acid? Most likely, yes. What about the second one?
Yes.
Yes. That's why these are more dangerous. Okay? It did what to the reading frame? Shifted it. Instead of TGT, I now moved it over one to AGT. Make sense? All right, let's do deletion. Deletion would be like starting with CCA, TGT, our original code, and mutating to CCT, GT. Now, if I bracket my reading code, then technically what is question mark? Whatever would have been the next letter beyond where I had written. Does that make sense? Yes?
Did you do
On this one? Nope. Nope. I've deleted a letter, and which letter did I delete? All right, so I want you to circle the A and cross it out. The A has been removed from the sequence, which of course made the T shift in the reading frame, which means the next reading frame is starting with GT, and this would technically be the next letter that would have been right here. Does that make sense? So now just ask yourself, if it was originally CCA and it's now CCT, would we say this amino acid has most likely changed? Maybe not, right? What about the next one though? Yes, and then more than likely everything after. Make sense? Okay, so I want you to look at the next section of your notes.